Hi everyone, in today's lesson we're going to talk about how to rewrite radicals and rational exponents with different indexes as one single radical. Okay, so just fix this up here for me please. This is unit 7 that we're beginning, exponents, and this is day 3. So let's talk about what I really mean. So if we look here, we have x to the 2/3 and then x to negative 2. And I can technically simplify these because I have the same base. So when I have the same base and I'm dividing, I subtract the exponents. But be careful, you're subtracting a negative 2. So it's 2/3 minus a negative 2. So if you type that into your calculator, what do you get? So type it in please for me and get a fraction. Okay, you should get 8/3. So this simplifies to x to the 8/3 to the 1/2 power. Now we're not done because technically I can multiply these two powers, and when I multiply, we're in the calculator, we're doing 8/3 times 1/2 and reducing that fraction for me. You should get 4/3. So this here becomes x to the 4/3. Now remember, if I want to write this as a radical, the bottom number is my root and the top number is my power. So it's the third root of x to the 4th. So this is our plan for today. Our plan is to rewrite weird looking expressions like this as one single radical. Now this first example was relatively easy because there was just one x. But what if I have x and y, and I want to write it as some root, the cube root? So if I just have one thing, this x, to the 4/3, that third is my root. So if I were to change even this to a radical, it would be a square root and a cube root. We can't have that. I want to write it under one common radical. So what we're going to need to do first is figure out a common denominator. So between the 2 and the 3, say you were adding them, which we're not, but that's what you want to think of when you think of common denominators. And you want to think of what's a common denominator between 2 and 3. You should be thinking 6. So if I raise this to the 6/6 power, now what's 6 divided by 6? Nothing other than 1. So I'm really raising this x to the 1/2, y to the 2/3, technically to the 1 power, which doesn't change anything. We're just doing a little manipulation. So we have to, if we want to get them to be the same radical, raise it to the common denominator, but 6/6. Okay? Now we can't just distribute the power in, unfortunately. We kind of have to break this 6/6 up. Do you agree that if I took 6 times 1/6, I would get 6/6. 6 times 1 is 6. Technically, I could put this over 1, right? 1 times 6 is 6. So that does work out. So what we're going to do is do this in 2 steps. We're going to raise it to the 6 first, then we're going to raise it to the 1/6 to get my total of 6/6. So bear with me. We're going to take the x to the 1/2, the y to the 2/3, and we're going to first raise it to the 6th power. Okay? And then we can distribute it in. So take 1/2 and multiply it by 6. You should get 3. And then we're going to take the 2/3 and multiply it by 6. And you should get 4. So if you see here now, we've raised it to the 6. We now can raise it to the 1/6. And now do you notice though, this is my root and this is my power. So now it's the 6th root of x to the 3rd, y to the 4th. Common root. So I've changed a square root and a cube root into a 6th root. So it's a common root. But what we had to do it in 2 steps. So by raising this thing to the 6th and then the 1/6, both of them still is the same thing as multiplying by the 6/6. We can explore this concept in detail a little bit more, but let's get the process down. Okay, so let's look at example number 1 down here now. All right, so the first thing we want to do is rewrite all radicals as rational exponents. So if this 4 is my root, and this 1 is my power, we could write this as x to the 1/4. And we could write this y, if this 3 is my root and the 2 is my power. We could write this as the 2/3 power. And we're going to square it. Okay, so we have to make it look like this problem here, where it was just x to some power, y to some power. So that's the step. Simplify all variables until it only has one exponent. So we're going to distribute this power in. So we get x to the 1/2, and then we multiply this, it's 4/3. So we get y to the 1/3. And now we're going to simplify this problem. So we need a common denominator between the 2 and the 3, which should be 6. Okay, so we're going to raise it first to the 6th power, and then raise it to the 1/6. Okay, which again is the same thing as doing common denominator over common denominator. So we'll distribute it in. So we get x to the 3rd, y to the 2nd. So now we have our final answer. If the 6 is my root and this is my power, I have the 6th root of x to the 3rd, y squared. Okay? So let's be very clear about the rules. We always have to write it as x to some power, y to some power. We raise it to the common denominator and then 1 over the common denominator. Those are the steps. So let's simplify this whole piece first. So I think I want to simplify the insides with the x's and the y's. So this y has a power of 1, but for the x's, I want to subtract 2/3 and 1/2. So in the calculator, type in 2/3 minus 1/2, and then hit math enter enter to get me a fraction. Okay, you should be getting 1/6. So we have x to the 1/6. Now let's do the y's. The powers for the y's are 1 minus 1/2. Type that into the calculator. You should get 1/2. So y to the 1/2. And now we're going to raise this to the 3/2 power. We're going to distribute this in. We're going to multiply 1/6 by 3/2, which should give you 1/4. And then 1/2 times 3/2, which gives you 3/4. So x to the 1/4, y to the 3/4. And look at that, they have the same denominator. So we could write this as the 4th root of x and y to the 3rd. Alright, let's see what's on the next page. Alright, so number 3. I know it looks a little scary at first, but it's not as bad as you think. Let's just take first all these radicals and change them to x to the power over root. So we have y times y to the 1/3 over y to the 0 is the same thing as saying 1 times x to the 1/2 square root times y to the 1/2 square root of y. And it looks as though we can multiply these powers, right? We keep the base of y and we add the 1 and the 1/3. So 1 plus 1/3. Type that into the calculator. You should get 4/3. And then the bottom is x to the 1/2, which I can't do anything about, and y to the 1/2. Now I can divide these by subtracting the exponents, so 4/3 minus 1/2. Type that into the calculator and get an answer. You should be getting 5/6. So we've got y to the 5/6 over x squared that we want to write as a common radical. So the common denominator between 6 and 2/1, right, is 6. So we're going to first raise it to the 6th power and then the 1/6. So when we multiply, when we raise, we can multiply. So this becomes y to the 30/6 and x to the 12th power. And we'll raise this to the 1 over 6 power. So this answer is really the 6th root of y to the 30 over 6, which is 5. If we simplify that, right? 30 divided by 6 is 5, over x to the 12th. That's that final answer there. All right, last but not least, number 4. This problem here, we have to first combine like terms. This is kind of like saying 5x squared minus 3x squared. That's 2x squared. Or 5x to the third minus 3x to the third is 2x to the third. So when I take these two and subtract them, it's 2x to the 1/5. Now, if we want to write it as one common radical, we have to look at the two powers. So this 2 has a power of 1, and the x has a power of 1/5. So this is technically 1 over 1. So the common denominator between these two things is 5. So we're going to raise it first to the 5th power. So we have 2 to the 5th, x to the 1st. When we multiply, right, 5 times a 5th is 1. 5 times 1 over 1 is 5. And then we're going to raise this to the 1/5 power. So we're going to take the 5th root of 2 to the 5th, which we can do. Just type that into the calculator, you get 32x. So we've successfully written this all under one radical. All right, jot down any questions that you might have at this point, and then we'll definitely practice all this tomorrow. Okay, have a good night.